And now we're going to move into our third unit of the semester. This was a pretty big one in terms of the fact that it comes back again at the end of the semester as well. This was our polynomials and factoring unit. And so inside of here, you needed to be able to add, subtract, multiply polynomials, and then use all those different factoring methods that we talked about in there. So for adding and subtracting, this is pretty straightforward. If you see a plus or a minus in between here, you are just adding like terms or subtracting like terms. So I'm looking at the third power and the third power here. That's a 3x cubed and a 1x cubed. Those add up to 4x cubed. The exponents do not change. It is like terms. They stay the same. You do need to note, though, that there is a 1 in front of that x to the third there. That's why I ended up with 4 over there. Then I'm looking at positive 2x to the second, negative 4x to the second. So 2 subtracting 4, I'm going to be left with negative 2x to the second in there. And the constant, negative 7, positive 3. It doesn't look like there's an x term here, so you could choose to put plus 0x, or you could ignore it. Subtracting those gets me to negative 4. Bing, bang, boom, done. That's it. The hardest that this could be for adding or subtracting is with the subtraction here, with this minus. We're going to distribute it into the parentheses here. And that's going to change this 3x, or x to the third, excuse me, to a negative, the negative 4 to a positive, and this positive 3 to a negative. And in doing so, it changes to a plus, and then you're doing exactly like what you did in the first one. You are going to combine the x to the third and the x to the third. 3 of them, subtracting 1, leaves me with 2 of them. 2x squared, positive 4x squared. Adding those up gets me to 6x squared. And negative 7, subtracting 3 more, gets us to negative 10. Again, if you wanted to, you could put a plus 0x in there. They're going to want this in standard form, so make sure your highest powers go first. 3, 2, if there was an x, that would be in between here before we get to our constant, and so on down the line. So adding and subtracting, don't do anything wild and crazy. You're just simply combining like terms in there. When you get to multiplying, so now you have 2 different strategies that we talked about. There was the box method, or there was the extended distributive property. Make sure that you know how to handle both. So I'm going to kind of show both of them here. The extended distributive property looks like this, where you multiply the 3x times the entire second binomial, the 2 times the entire second binomial, and now you're going to distribute. The 3x goes in here, 3 times 5, x times x. Now the exponents stack. You are not adding anymore, you're multiplying, so the powers get bigger. Multiplying here, 3 times negative 4, and there was an x out front. Now I've also got to distribute the 2 in there, so 2 times 5x is 10x. 2 times negative 4 is negative 8. We need to combine like terms. That's these 2. They both have x's, so now you are not stacking the exponents, you're just combining them. So the 15x squared is part of your final answer. So is the minus 8 from over here. And adding up the negative 12x and the positive 10x, we're down at negative 2x. There's our expansion in there. If you instead would prefer to do your box method, if you're like, no, I think that one worked better for me, then we're going to put the 3x and the 2 up here, and the 5x and the negative 4 on the side here. You could switch which one's on the top and which one's on the left. That makes no difference. But we're going to now multiply them together. And this one times this one's going to get me 15x to the second. So 3x times the negative 4 will get me negative 12x. 5x times this 2 is going to get me 10x. And the negative 4 times the 2 is going to get me negative 8. Notice those are the same 4 things I wrote up here. And now we have to combine the like terms, and it would still get you to this same thing in the end in there. So same deal here for the other one. You can choose how you want to handle it. If you decide that you want to go with the box method, this one's just not going to be a 2 by 2 box. We would have to do like 3x with 2 here, and then the x squared up top, the 1x, and the negative 10 here, and we'd end up with 6 things inside of there. If you choose to do the extended distributive property, we just got to make sure that this 3x gets distributed into all 3 of these, and the 2 gets distributed into all 3 of these, resulting in the same 6 numbers that are about to show up in the box here. So 3x times x squared will get me 3, stack the exponents, x to the third, because this is like an x to the first here. 3x times 1x will get me 3x to the second, because this one's also like a first, so those ones add up. 3x times negative 10 is negative 30x. Second row, 2 times x squared. Just throw them together. 2 times 1x, 2x. And 2 times negative 10, negative 20. Now we need to combine everything we can. These are both squareds. These are both x's. There is a 3x to the third. Adding the x squared terms, we've got 2 and 3. That'll get me to 5. And adding the 2x terms will be at negative 28x, because 2 subtracting 30. And then that minus 20 is left over there. There's our standard form final answer. Same thing you would have come to if you did it by the extended distributive property. It's totally your choice. They're not going to ask you on the final to do it one way or the other. You just have to know how to expand. Just don't do this on the adding or subtracting ones. Do not start drawing boxes out for these first couple. You're just combining like terms when there was a plus or a minus in between the two. When there is nothing in between, that's when there is a multiplication. Now that's your indicator that you should be doing the box method or you should be doing the extended distributive property. All right. For the rest of this unit, the name of the game was factor, 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 factor. And so one of the things that we talked about is the fact that when you have, actually in this case, I'm going to get rid of the a here. This wasn't actually meant to be here. If we have a 1 in front of the x squared instead of some other number, there are definitely prescribed ways that this thing is going to factor for us. 2 positives. We're looking for what multiplies to c and adds to b. Those always break into 2 positives. What's going to multiply to a positive number here and add to a negative? Well, 2 negatives could multiply to a positive as well. If the c value is a negative, however, you need one of each, a minus and a plus. Now, which one's going to be bigger? Since we want the total to be a negative, we need the bigger value to go with the minus so that it overwhelms the positive smaller number in there. And vice versa for the bottom one. To multiply to a negative, we need one of each. But which one should be the bigger, the positive or the negative? In this case, we need the plus to be the bigger one so it overwhelms the smaller one. I'm not sure that you need to write that down on your note sheet. However, it is something that we should be aware of and pretty good at using our MAF, multiplies to, adds to, what are my factors strategy. Here's essentially our flow chart of what you should always try to do. Please don't forget to try the GCF. Is there a greatest common factor you can take out first? If there is, do that. After that point, what do you have left? A binomial, a trinomial, or 4-term polynomial, and that's going to determine which strategy you might still be able to potentially do. Each of these, difference of squares, perfect square trinomial, those two could be caught by doing the MAF strategy, but if you recognize the perfect squares, that should be easier. You don't even need MAF. The quick MAF versus long MAF, we've talked about that a bunch. We'll look at some examples in a minute. And grouping is a specific situation we're going to use when we end up with 4 terms in there. So the rest of what I've got here is a few examples, pretty much some of each. Completely factor. So please note, this is not solving. So the unit we just wrapped up here at the end of the semester had like an equals 0, and you were supposed to give a number like x equals 4 or whatever it's supposed to be. That is not the case here in this part of the units. You were supposed to just write them into the parenthesized groups, and that's it. So like this is a GCF. There is a factor of 2 that goes into both of those. So if I divide a 2 out of each, it gets me down to 9x squared minus 4. Now inside the parentheses, I still see a squared, so I should see, is there another strategy I could use that would allow me to simplify this out? There is. This one is now our difference of squares method in there, because 9 is a perfect square 3 times 3. 4 is a perfect square 2 times 2, and it is a difference. There is subtraction, which means that I can write the two sets of parentheses, 3x times 3x, that's where my 9x squared comes from, and one is a plus 2, one is a minus 2, that's where multiplying to get a negative 4 comes from. That's my full factorization. Once you get it down to x to the first in the parentheses, there's no squared left, you are definitely done. So that really had two different strategies. The next one, this is also a difference of two squares in here. You've got 1, which is 1 times 1, so 1x and 1x. And you got 25 here, which is like 5 times 5. Since it is a difference, 1 gets a plus, 1 gets a minus. In there, if you need to prove it to yourself why that works, then you need to go ahead and use the box method or the extended distributive property and prove it to yourself that if you expand that back out, the middle term drops out in there. This next one, again, I'm kind of noticing, hey, 4 is a perfect square. 9, oh, that's a perfect square. That probably means that what I'm dealing with here is a perfect square trinomial in there. All right. And so the first thing that I would try is, let's try 2 with an x in each of these, and let's try 3 in each of these. Now, what I've got to make sure is, can I get to this negative 12x from here? And so what you would want to be looking at there is, if I multiply these outside 2 and these inside 2, could I get to negative 12? The outer 2 multiplied as 6x, the inner 2 multiplied as 6x. I need it to be negative 12. If I could somehow make these both negative 6s by just putting minuses in here, all of a sudden we're in business and we've got the correct factorization for this one. What you also should realize is that this could be rewritten then as the binomial to the second power, instead of writing that binomial twice, because it's literally the same thing. Couldn't do that over here because one was a plus, one was a minus. But if they both have minuses in here, then we could write it as that binomial to the second. Technically, instead of difference of squares and perfect square trinomials, you could do the MAF strategy. It's just, if you're noticing, that's 5 times 5, 2 times 2, 3 times 3, 2 times 2, 3 times 3. Those ones should be things we could factor quicker. These are the ones then that, yes, we are going to use that MAF strategy or our grouping strategy. So when there is a 1 in front here, that's telling me that this is going to be my quick MAF method. So it multiplies to the C value, our negative 12. It adds to the B value, that's our negative 4. And we need to find a pair of numbers that will multiply to negative 12 and add to 4. So I'm going to list out my pairs for 12. I need it to multiply to a negative, so one of these needs to be a minus. And since I want it to add to a minus, this is the situation where I need the bigger one to be the minus in here. So which one of those pairs will now add to negative 4? It's this one, the 2 and the negative 6. So our factorization, one of them gets an x with the minus 2, one of them gets an x with the positive 2, and one gets an x with a minus 6 in there. You are done. We are not solving. Do not write x equals and then switch the signs in there. You're just factoring at this point. There's no equals 0. We do not have to complete the rest of it. Don't do more than you have to on the final exam. The next one, this is not 1, which means this is more of that long MAF approach, which is going to require us to essentially break it into 4 terms and create a grouping situation out of this. We still are going to start with MAF. What you need to do is multiply the A and the C values together to get your multiplies to number. It's not just -5. That 6 in front of the x squared has to play a role in it as well. Then we're going to find our pair of numbers. So for 30, we've got all sorts of possibilities that can multiply to 30. There they all are. I need it to be one of each because I do need it to multiply to a negative. But I want the total to be a positive, which means the bigger one has to be the positive. So the negative is really going to be my small one. Which pair gets me to a positive 13? It's these two. So now the difference here between quick and long MAF is I'm going to leave that first term alone. This middle one is now going to break into -2 with an x and positive 15 with an x. Those numbers came from right here, the -2 and the 15, and then the -5 stays put. Now what we need to do is group this. We've gone from 3 terms to 4 terms. What can I take out of each? Out of these two, it looks like I could drag out a 2x. So by doing that, that'll leave us with 3x minus 1. So notice when you take the -2x divided by 2x, yes, I know the whole thing seems to come out. We do need to have something to hold the place here. So if 1 has to be left in there, 1 has to be left in there. And here we can divide by 5. So we'll take out a positive 5, leaving us with 3x minus 1. If this has worked, the things in the parentheses are identical. They are. So now we can write our final answer. One of them is that 3x minus 1. The other is going to be a combination of the two things that you dragged out, the 2x and the positive 5. This is my answer in there for the factorization. And so what it means is that the numbers here ended up being things that are not 1. Over here we had just numbers that were 1 in front of there. This last one, there are 4 terms. Instantly you should be thinking, I should probably try to group that thing. So the same thing we just did. What can I take out? X squared, 9, 9. And so that is going to get me x plus 1. X plus 1. We put these together. The common one goes here. The stuff that got taken out goes in here. And now this time I am looking at that going, oh, but that's an x squared. Could I do something with the difference of squares? That's not a difference. It is a sum. It's an addition. There's actually nothing we can do. That's as good as we're going to get. But if that had worked out to x squared minus 9, you better believe you should have done another factoring step with the difference of squares.